This is a video lecture series for middle school science where you'll be able to play this video, but anytime you'll be able to pause, fast forward, or rewind within the video. And this lesson is going to focus on reflection and mirrors. So if you've ever looked at yourself in a smooth surface, you might be able to see a reflection or an image of yourself from there if it's a smooth surface. But if you've ever gone into a fun house, you might actually see different images of yourself where the images are actually going to be distorted and the shapes are going to be different. So where you might actually look like you are taller, or you might be shorter, or you might be fatter or thinner. And we want to try to understand why is it that you might actually look different in those types of mirrors, or why you might look different in different types of surfaces. So if you ever try to look at a pond or at the swimming pool or in a river, if it is calm and smooth, you might be able to see a reflection of yourself. And you are able to see a reflection of yourself because the light from a light source like the sun might actually come and reflect off of your body, will actually go onto the smooth surface, like the water here, and reflect right back to your eyes. So what you're seeing is a reflection of that light off of the surface on your body here. And it's only when the surface of the water is smooth that you'll be able to see that reflection. Now, if we actually have it be a windy day, or if the surface actually becomes rough, or there's waves that are actually coming on here and the surface isn't smooth, then when that light actually comes and reflects off of body here, it's not going to reflect right back to your eyes. It might reflect off in different directions, and you might not see a clear image of yourself. Or if we have a straight type of mirror, and if you look at a mirror and you raise your right hand here, if you look at the reflection, you might actually see an image of someone, and it won't be their right hand that they're raising, but it might be their left. And you'll see the opposite appearing within the mirror. Or if you have printing, you might actually see the printing come out backwards. And the point is to try to understand why. Why does that occur when we actually look in a mirror? So here are some of the reasons why that might actually occur. So the law of reflection is that the angle of incidence is equal to the angle of reflection. Now that statement might be confusing and it might be difficult to understand. But basically what that's stating is that if light actually comes and hits a surface at a certain angle, it is going to reflect off at the same angle of that reflection. So the reflection is actually going to come off at the same angle at which it came. Now, if the surface is rough, it is going to create a diffuse reflection. So a diffuse reflection is going to be a reflection off of a rough surface, where that light actually comes, hits, but it might not reflect right directly back to your eye. While a regular reflection is going to be the opposite, where reflection off of a smooth surface will actually yield a clear image. So here is going to be an example of that law of reflection. So if I have a light source from like a flashlight or a laser pointer, and if that actually comes and hits a straight plane mirror, and if it is a smooth surface, then that light is actually going to come, hit at a certain point within that mirror, and it'll actually reflect right off. Now if we take a look at the angle at which that light actually came and hit the mirror, that is going to be the same angle at which that light is actually going to bounce off and reflect. So here, this here is known as the angle of incidence. And this over here is going to be the angle of reflection, because here we have the light actually reflecting off, and this is my light ray that's reflecting off of the mirror. And this angle is going to be the angle of reflection. Now both angles are going to come off of this imaginary line that comes right down the middle here, and that is going to be known as the optical axis. So some of the rules that also exist with mirrors, and some of the things that you might observe, is that the object that's being reflected, or the object that's actually in front of the mirror, is going to be an equal distance from the mirror as the images inside of the mirror, and what it is that you're actually seeing. So they are going to be at equal distances. So the object and its distance away it is from the mirror is going to be equal to the image and its distance away that it is from the mirror. So the farther away the object is, the farther away that the image is going to look like it's away from the mirror. Or if the object is closer, then the image is going to appear closer. Now a concave mirror is going to be a mirror that's actually curved or bent, and it's going to be bent inward like a cave. So this is like it's caved in. So this is going to be a concave mirror. While a convex mirror is going to be curved outward. So a convex mirror is going to be curved in an outward fashion. So the optical axis, as mentioned before, is going to be an imaginary line that goes down the center of a mirror. So the optical axis is an imaginary line that will actually go right to the center of that mirror. Now, some of these mirrors will actually create something called a focal point. Now, the focal point is going to be a point where all the light converge, or where all the light actually comes together. So if there's a point where all that light comes together, that is going to be called the focal point. Now, certain types of these mirrors are actually going to create a focal point. One of those types of mirrors is going to be a concave mirror. So concave mirrors are going to be where I have a light source, like a candle. And if that candle actually comes and hits this mirror and it's curved inward and caved in just like this is going to be a concave mirror. So what's going to happen with that light is when that light actually comes and hits that concave mirror, it is going to go through that law of reflection where it bounces off at the same angle at which it actually came in. So when that light actually comes and bounces off, all of that light is actually going to come together at this one point, and that is going to be called the focal point. So this over here, where all that light actually comes together, is going to be the focal point. Now, if I have the object here that's past this focal point, and we look at that image in the concave mirror, if we are beyond the focal point, then that image might actually appear upside down inside that mirror. But if I have the object within that focal point, and not past it, if it's within that focal point, then the object inside the mirror might actually appear right side up. So this over here, if I take that focal point and I measure the distance from that focal point to the mirror, that is actually known as the focal length. And the focal length is going to be the distance from that focal point to the mirror. So if the object is within that focal length, then that object is going to appear right side up. But if we go past that focal length, past that focal point, and we're beyond it, if we look at the image is going to appear upside down. So some places where you might actually see concave mirrors is going to be like in a flashlight. So you're going to have something reflective inside of here, and it's going to be caved in. And then you are going to have a light bulb. That light bulb is normally going to be here at the focal point, and when that light actually comes, it is actually going to all flash outward, and inside here is going to be concave. A satellite dish is going to be concave because I'm going to have electromagnetic waves that are going to come here, and they're going to come and try to hit at a focal point, and there's a device here to try to take all those waves in at that strongest point. Or a speaker is going to have something that's concave here to actually let the waves be able to be transmitted, and that energy be transmitted out from the speaker. Now the focal length, once again, is the length of the focal point to the mirror. So we go from the focal point and measure the distance from that focal point to the mirror. That's going to be known as the focal length. Now, if the object is farther away than the focal point, then the image will actually appear upside down within a concave mirror. So if I have a concave mirror and if the object is farther away than the focal point, the image will appear and will be upside down. Now if the object is within the focal point, the image will be right side up. So once again, that's going to be in concave mirrors. If the object is within the focal point, the image will appear right side up. Now in a convex mirror is going to be curved out. And if that light actually comes and hits it, the image will actually appear upright and it's going to be smaller. So here is a convex mirror. And what's going to happen is if I have a light source and that convex mirror is curved outward, then that light is actually going to come hit it, and that light is going to diverge, and that light is going to move off in other directions, and if it's going to scatter, and because of that, the image is going to appear upright and it's going to appear smaller. So if I have a light like here, and if my mirror is curved outward, then that is going to be a convex mirror. Some places that you might see convex mirrors are going to be like on the school bus. You might actually see the bus mirror on the side over here, and then we'll actually see a small little curved mirror on the bottom over here. That is going to be a convex mirror, which is actually going to make all the objects appear smaller. Or like if your parents have a car and they have a side mirror, sometimes there might be a message on there that says objects may be closer than they appear. And if that is, then that means that there is going to be a convex mirror that's there. Now here, you might actually go into a shopping center, and if you see clothing, or you try to go shopping, they might actually have a mirror on the top in the corner. Now that mirror is going to be curved outward, and it's curved outward to make it so that everything appears smaller, so we can actually fit more of the image within that mirror, so somebody else can see if there's anything going on. They are going to use convex mirrors to help with that, so they can actually try to see more. So some of the ideas that we should have learned from this lesson are going to be the law of reflection, diffuse reflection, regular reflection, convex and concave mirrors, the optical axis, the focal point, and the focal length.